Corrosion of steel is a fundamental process in nature which costs us dearly. Rust causes billions of dollars of damage every year to our nation's highway bridges and other steel structures. In 1983, a 100-foot section of the Mianus River Bridge on the heavily traveled Connecticut Turnpike collapsed. A report by the National Transportation Safety Board concluded that the probable cause of the disaster was due to corrosion-induced forces. Do the ravages of corrosion have more catastrophes in store? The Departments of Transportation in all 50 states rate 140,000 of the 574,000 bridges in the U.S. as structurally deficient. Approximately 90,000 bridges have exceeded their 50-year average design life, and some 25,000 were built before the turn of the century. The cost of combating corrosion on the United States' aging bridges was $50 billion annually, according to an estimate made by the Federal Highway Administration in 1982. The figure is projected to grow by another $5 billion per year. Road closings, traffic jams, detours, and the resulting time delays and lost commerce are also related to the corrosion of our bridges. Until now, paint has been our prime weapon in the battle against corrosion. But recently, transportation officials in the United States and Canada have been evaluating an improved corrosion protection process. It's one that has been used in Europe for decades, providing longer-lasting protection than paint coatings. The focus of their attention is zinc metallizing, a process in which zinc or zinc alloys are melted and sprayed onto a steel surface. The molten zinc particles create a layered coating, one that offers not only barrier protection but galvanic protection as well. This means the zinc will corrode in preference to the steel and will continue to protect it as long as any zinc remains in the immediate area. The simplicity of the metallizing process makes it ideal for both on-site and in-shop application. Blasting to white metal removes surface contaminants and creates a surface roughness for improved spray metal adhesion. This is a cross-section of a zinc metallized coating. The porosity shown here enhances the adhesion of sealers and top coats. Whether top-coated or left to work on its own, the key advantage of zinc metallizing is long-term corrosion protection. Consider the results of a 19-year study conducted by the American Welding Society. 4,000 steel panels were exposed at ASTM test sites across the United States for almost 2 decades. Many of the zinc metallized panels look ready to go for another 19 years. But what of the economics of zinc metallizing? Simply put, the process's superior corrosion protection makes it more cost-effective when total life cycle costs are considered. Life cycle costs include both the initial application costs and the costs necessary to maintain the coating over the life of the structure. The Ridge Avenue Bridge in Philadelphia proves this point. It was zinc metallized in 1937. Today, its original zinc coating is still intact after almost a half-century of service. Based on its initial coating cost and 50-year maintenance-free life, the life cycle cost of this structure is less than ½ cent per square foot a year. Jack Childs, whose company worked on the bridge in the 30s, explains the economics.
The bridge that we're looking at here is over Ridge Avenue in a heavy industrialized area of Philadelphia. Back in 1937, our company sandblasted to a white metal finish the underneath or trough side of this bridge and applied a 10 to 12 mil coating of wire sprayed zinc. About 2 years ago, SEPTA cleaned off the underside of these troughs in order to get an idea of how well the coating was still doing. Those are the white areas that you see up here. This cleaning revealed that the zinc coating was still in place and of very good thickness and still providing the protection that was contemplated back in 1937.
The quest for long-term protection has prompted the Ohio Department of Transportation to begin an experimental program designed to evaluate zinc metallizing. The Ohio DOT selected 2 bridges to be zinc metallized by the Akron Sand Blast and Metallizing Company of Barberton, Ohio. Al Kay, the president of the firm, has the details.
This bridge on Route 229 near Delaware, Ohio, is the first bridge in the state of Ohio to be metallized. The specifications and the procedures that we are following on this bridge are pressure washing using a detergent. After the girders are allowed to dry, sandblasting to white metal, spraying with zinc with a 6 to 8 mil coating, and at that time, and each evening sealing the area that has been metallized. After all the metallizing has taken place, we will then apply a 3-coat system.
Akron Sandblast and Metallizing Company's next project for the Ohio program is this 364-foot by 32-foot bridge which spans Interstate 71. Preparation of the surface was the same as that used on the first bridge, but that's where the similarity ends. This time, the wire being fed into the metallizing gun is an alloy of 85% zinc and 15% aluminum. The 8515 material is a dual-phase alloy combining the best characteristics of both zinc and aluminum. The zinc-rich phase sacrifices itself to protect the more noble steel. The aluminum-rich phase, meanwhile, acts as a passive barrier against harsh corrosive environments. The improved characteristics of the 8515 alloy make it suitable for use in industrial atmospheres, marine environments, and where highway de-icing salts are used. As for the Interstate 71 bridge, its zinc metallized coating is topped with a clear sealer. Since a zinc metallized coating cools upon contact with the substrate, sealers and top coats can be applied immediately.
This application is a 2-component urethane applied to build a dry film thickness of 1 to 2 mils. It actually fills in the porosity of the zinc and provides a weather-resistant coating over the peaks of the metal surface. The application of a clear coating in this case is not the only means of protecting it with a urethane. It could be a colored paint to provide decorative appearance to a surface. In the case of a paint or an enamel finish, it would extend the protective life between repaintings probably in the area of 15 to 20 years. This would be on top of the expected metallizing life of the range of 30 to 40 years. This 2-component urethane has been through several thousand hours in salt fog testing with excellent results. The indications are that it is the most durable type of coating that could be applied to a metallized surface.
While state transportation departments are rediscovering the use of zinc metallizing to protect highway bridges, the process has been a favorite of many other industries for years. Water authorities have used zinc metallizing since the 1930s. In fact, zinc metallizing is approved by the American Water Works Association in its D102 standard for painting steel water tank interiors. And there's more. The wellheads on offshore oil rigs are zinc metallized to guard them from the ravages of severe salt splash and the saltwater atmosphere. Zinc metallizing is used for many onboard applications, including the topsides of ships, where the going really gets tough. Metallized zinc protects structures in remote areas, such as this footbridge. It spans the 13 billion-gallon Lake Gillard Reservoir in Connecticut. Boat trailers and trailer hitches are excellent applications for zinc metallizing, as are flood and pollution control gate locks. There is a definite need for long-lasting corrosion protection of any structural steel exposed to today's corrosive environment. Metallizing with zinc or zinc-aluminum can better fill that need for a simple reason. The process produces a coating that lasts longer by decades than paint alone. That makes metallizing with zinc or zinc alloys the cost-effective champion, time after time after time.